Yep. Morning, everyone. This is gonna be the fourth and the last session for this course. We would have alternative, classes which will happen by mid-June, but those sessions would be completely optional. You can either join them or you can choose not to join them. So I was kind of thinking that it would be nice if we could kind of together look into ideating a particular grasshopper script with respect to a reference image. So I was looking online and I kind of came with this image. So I thought it would be interesting for you people to, see how we could kind of ideate this back in, Grasshopper. Let's just get started. So if you see over here, the base is literally a hexagon. So this is a hexagon. Just that the hexagon kind of has few sides which go down, few sides which go up, and then you've got these curvilinear structures which are happening, and then the base. So there are three parts to this particular project. So we'll kind of start on it one by one. So I'm just gonna dock this somewhere here, so you can keep seeing it. Just give me a moment. Yep, very sorry about that. Let's get started. So we've got the image here. I'm keeping it as small as possible, or we can quickly bring this back into Rhino. So let me just drag and drop picture. So yep, that's our image. So we are going to be building everything from scratch. So let's kind of just have a marker point and set it up here. So I'm setting one point. So if you see the base over here is a hexagon again. So we're going to start with that. So I'm using a polygon. That is where the polygon is going to be. The radius, since it's millimeters, will keep somewhere around 0.100 mm. That's the radius. Okay, it's going to be a little bit bigger since it's a millimeter file. I'm just going to make the image a bit bigger. So there you go. I can just log this. So this is our hexagon. Now, what we are gonna do is we are gonna kind of look into the canopy. So let's consider the hexagon that we've done as something that happens over here, and now we are gonna work towards the top. So it's if you remember, three sizes of curves can be joined together to any day make you know like a canopy structure. So we are going to be doing the same here. So I'm gonna quickly move this. Move. So this is the base. I'll keep this in the bottom. I'm moving this by a height of, say, I'll have a maximum of 3 meters. I am gonna connect a unit Z and plug this in. So 3 meters is a lot. Let's get it down to, say, like somewhere around 1.2 meters. Yeah, that sounds good. Now we need to scale this. So I'm gonna use a scale function. This is a geometry. For the center, we need to find area centroid and then plug it back to the center. And I'm gonna give a factor, so I can kind of like increase the size. So I'm gonna give, say, 2 to 10 times the multiplication. I'm scaling the factor up. So there you go. We can scale this up. Good. Now, next what I need would be the third surface. So let me just group this. I can just make a copy paste of this, bring it back here. And so over here, I have to move this by another height. So over here, but what I can do is, like I can link these together, but for now we'll kind of like look at linking data a while later. So I'm gonna quickly hide all these. Yeah, no. So again, over here, I can play around with the scale factor. And what I can do is kind of like link the scale factor to this. So I have this number slider. So I can do a division, connect the slider here, have a panel with states 2, and connect it to this. So this becomes half the previous value. And so now just this one number slider will make sure that, like I kind of like control both of it. Good. Now we've done all this. So this is the base, and like we've got all this, but let's kind of like reduce the height a little bit. Yeah, that seems much more doable. Now again, like I just wanted to teach you how to connect these, but for design factors, let's just keep them a bit free flowing. Let's decide them on with respect to how the surface gets formed. Now, so now that this is done, the second step that we need to do is kind of like make. So we've got all the sectional curves. The next thing that we need to do is kind of like talk about how alternating points in this hexagon. So imagine this to be a hexagon. How every alternative point has been lifted up to get this kind of like a form function. So by that, what I mean is, I'm going to take every alternative point 1, 2, and 3 and move them by a height. Okay. So yeah, what I'm going to do is first get the edges. So to get the edges, I mean vertices, we use deconstruct derep. Now I've got all the vertices. So now I just have to split them. To split them into, like consecutive lists, I'm going to use dispatch. The initial pattern is itself a true or false, like, so it it shouldn't be that big a problem. Say if I just put a point component and connect this and hide this. you'll see that 3 alternative points are being selected. Let's hide everything else for now. So yeah, let me just open up the hexagon. So there you go. So now I kind of like need to move these points up. So I'm gonna use a move function. Now I can connect our geometry, delete this. So you're moving those 3 points in Z axis to a height of, say, we can have a maximum of 1 meters. So I can do a 1 lesser than 1000. So if you see, like this is going to give you that alternation. Now, these are the first set of points. Now we've got a second set of points, which are, let me just, these are the second set of points. And then we've got a midpoint from the area centroid. So this will get me my midpoint. So you've got midpoints and all those alternating points. So we just have to patch a surface between these points. So what I'm going to do is patch a surface between the midpoints and the edge points. So I'm going to get surfaces like these. Now what I'm going to do is use a 4-point surface. So you know that 4-point surface will even create a surface with just 3 points. So I'm just going to connect these 3 points. Nice. Don't worry about the the other 3 sides. We can just mirror them in the end. So don't worry about that. So we've got our surfaces. Now, second that we need is, we need lines. So if we go back to the image, you've got lines which kind of like connect like this. So now I kind of like need to subdivide all this like this. So what I'm gonna do is I'm gonna quickly get these curves and then these curves. If you take all these A curves, make these B curves, they are just a line connecting from the center point to the edge point. So I just have to take the center point and edge point and draw a line. So where are the center points? This is my center point. These 3 are my edge points. So I can just draw a line and connect this and this. I've got 3 lines. Yes. Now, for the second set of lines, for the B lines, I can take it from over here. So I can again do a deconstruct B rep. I'll get everything. I can just take its edges and I can list the first set. So I'm gonna list item. So now if you see these 3 are getting selected, we want these 3. So instead what I'm gonna do is give a index which kind of like 0 to 3. One is again the other set, so it should be 2. So since it's a fixed value, like we can fix a panel over there. 0 2. Let me connect this to my index. There you go. So you've got all those three edge curves. So now I need to draw a line between these two. Again, this is going a bit long, so I'll start grouping them up together till the surface. Now we are making those subdivisions. So I just have to do a divide curve for both of it. 1, 2. I'll give a, I'm very sorry, give me a minute. Yeah, so I've got the first set and the second set. Now I'm just gonna have a number slider. There you go. Now I can just draw a line between them. From here to here. Okay, so what's happening is one of these curves are kind of like in one direction, the other is another direction. So you need to flip one of these curves. So I can flip this line, flip. Since I've listed this, like it's better that, like the problem here is the direction. The direction for these curves would be like this, whereas the direction for these curves would be like this. So the first point here and the last point here is getting connected. So this kind of like gets you the current output. So we just have to flip the curves. So I'm flipping this and plugging this back again. So yes, see, now we've kind of like got the required lines. So we've got the surface, we've got the lines, we've got the surface, we've got the lines. Now we need these arc poles. So if you see, we kind of like have two more of our hexagons. And these hexagons, what we need to do is kind of like find these points and then just draw arc around there. So I'm gonna again, like take a copy of this from here, connect it here. I've got 3 points. Yes. Now I'm gonna do the same, Control C, Control V, and connect it to my end polygon. So I've got again a set of points. So I've got 3 set of points, 1, 2, and 3. Now I just have to interpolate a curve. So instead of interpolating, we'll just use a spline curve. So in curves, you can use a NURBS curve. So this, I just have to plug in my vertices. But before plugging into the vertex, or like, I can teach it to you with the reference itself. So if I connect all these together, you'll see that the curve kind of like spirals down. So all these points are getting, like weaved together. That is because if you take a list, you'll see that this is a single list. And then this is a single list. So what happens is, like the curve starts interpolating, or, like making a control point curve from this point, this point, this point, this, and again the last three. That results in your singular curve. So what we need to do is split all of those. So I'm gonna make a quick graph. So if you see, you've got 3 different lists. I'll graph this also, and I'll graph this also. So see, now what happens is this gets connected to this and this gets connected to this in the third list, this to the third list. So you imagine you have another list which connects back to this point. So well and good, like we've got our curves. The degree must be lesser than the number of control points. hmm It's not a big issue, but like you can change it or you can drop it and it shouldn't be a problem. Now, if you see, I've got all these curves, and now like if I kind of like play along with these values, I can play with the form factor. No. Mm, I can play with the factor. I can play with the height. There you go. Now I don't want this hexagon, so I can hide it. So that's great. Now I wonder why, like these are getting highlighted. Oh, so because I kind of like flattened here. So instead of doing this, I'll kind of like graph this, ungraph this, connect this to this point, and plug this back in. But if you see, the loft is kind of like, because I'm kind of like giving a different weave pattern, like it's happening in another wrong way. So two, one, two, and three. Yeah, that seems better. Now, if I go back to the image, you will see that, like this curve and this curve are getting connected. So from here to here, there's a connection. Here to here, there is a connection. Let's try doing that right now. So over here, what I mean is we want to divide this curve into multiple points and then connect these back here. All right, let's quickly, like do that. Now what I'm gonna do is, like divide this curve. So this is our curve. I'm gonna use a divide curve. I'm gonna use the same amount of count as before. So I'm doing a divide curve. Well and good. Now let's see which of those points are the upper points. These are the upper points. I'll just bring them here. Let me group it here. So these are the upper points. These are the arc points. I'm gonna draw a line from these to this. There you go. We've got this also happening. Now it is happening on three planes. We just have to, like make it happen on the other ends. So for that, we need to give a mirror plane. We need three. So if I give a mirror plane, it's gonna mirror according to the plane. And over here, since we need to kind of like mirror it across, let me take an annotation. So since we need to mirror it across one like this, one like this, I'll use those as a planes. So for reference,